Department of Information Technology, second year from IIST Sripur. So I'll be taking your session today on binary search, and Simit will take your session on divide and conquer. So let me present my screen first. So is my screen visible?
Yeah, it is visible. Anushka.
Okay, all right. So so we'll be talking about searching algorithms first. So let's see. So So the most common searching algorithms that we know of are linear search and binary search. So linear search and binary search. Linear search can be used on any kind of array for searching a particular element, and binary search works only for a sorted array. There are other types of searching algorithms too, like jump search, interpolation search, but we'll only look at uh, binary search, mostly focus on binary search on today's session. So linear search is when you have an array. Let's say this is the array and you have some numbers, and it might be sorted, it might not be sorted, so we can have anything. And suppose you're trying to find 11 here. So what, or maybe 23 here. So what we are going to do is check one by one each and every element. So we are going to check check on the first element first, then second, and we'll break whenever we find our required element. So we'll break here and it breaks here. We found it. Suppose we were searching for 45, then we would have to scan the entire array. So in that case, we are checking everything in the array. So the maximum, the worst case that we can have here is check the entire array. So my time complexity for this becomes O of n for linear search. Now, if we have the array in a sorted order, so if we have our array in a sorted order, in that case, we can take advantage of the fact that the array was already sorted, and we can take advantage of the fact that the array was already sorted. So we can use a algorithm called binary search. In that, what we do is uh, we are going to check the middle element. So before I explain this, let me take an example. Like when you are searching for a word in a dictionary, suppose you want to find the word maybe shark. You want to find the word shark, and you are flipping through the pages randomly and you landed on a page with words starting from M. So what are you going to do? So you suppose you landed on this page with the words starting from M. So are you going to check the left side of the dictionary anymore? I don't think so, because it'll have words starting from A, B, C up to M, not S, right? So S comes after M. So you are going to ignore the left part of the book. You're not going to check for the word shark in the left part of the book. You're going to check in this. You're going to turn the page this way and check on the right half of the book. You can might as well just tear that part of the book apart, and it doesn't matter. You'll have to check after M. So this is the thing that we can use here. So this is some binary search is the same thing we are doing here. We can divide the thing. We can suppose we are at 23 and we are searching for 75 here. We are searching for 75 here, and we saw, and it is the array is in a sorted way. So if we found 23, we are at 23 at the element where index where we have the 23, then we do not need to check on the left side of the array because we know the array is already sorted, and everything on the left of it is going to be smaller than 23. So we do not need to check on this side of the array at all. We can just check on the left side, right? So let me take a bigger example so that we can see it even better. Let me take something like 2 7. So what we are going to do is take the middle element. So in case of the thing, if you're thinking about a dictionary, then what you're doing is uh, opening the middle page of the book, and then you're seeing that if it's okay, if it's M, then I need to go on the right side to find shark. I do not need to go on the left side because my word starting from S is never going, any word starting from S is never going to be on the left side of the book. So in here we are doing the same thing. So suppose we are trying to find 88 here. So our element that we want to find is 88. So we are taking the middle element first. Middle element. So there's, this is 0 index, this is 1, this is 2, this is 3. So these are the indexes. Okay. So I am taking the middle element. So 0 plus 8 is 8 by 2, 4. So this is my middle element. So I'm checking now. Is 88 smaller than 32 or greater than 32 or equal to 32? So it's greater. So I can entirely ignore this entire part of the array because it's never going to be on the this side of the array. We can also ignore that because this is also not a part, this is also not 88. So we can ignore this as well. So we are going to check from here now. We are ignoring the left part of the array and we are going to check from here now. So now we are taking, so this is our array now. This is our array. Now in this array, we are taking the middle element again. So there are actually two middle elements here. You can take any one of them. It doesn't matter. The thing is that you are reducing your problem into half each every time. So it doesn't matter if you take this as the middle element or this. Let me take this. This is your middle element. Let's say. So is 88 greater than 56 or smaller? It's greater, definitely. So I can ignore this part of the array again. So I have now this part. This is my array now. So I do not need the rest part of the array. So middle element, I was taking the left side first. So I'll out of 88 and 90, I'll take this one as middle element. So is this equal to X? Yes, it is. So we found our element, right? So how many operations did we do here? We did 3 operations. We found the middle element in the whole array once, ignored this part of the array. Then we found the middle element in this part. And then we found the middle element in this part. We did 3 operations in binary search. But if we had used linear search, that is check each and every element one by one, then we would have taken 7 operations. We would have taken 7 operations to get here, 8 operations. If we have taken checked each and every element one by one. So let's think about the algorithm, what we are doing here. Uh, let me take the same examples. So we had 2, we had 7, 15, 23, 32, 45. So to consider, we are only considering half of the array at one time, right? uh, we are reducing the size of the array by half every time. So for considering the length of the array, like which part we are considering, we have to this one upper bound and one lower bound, which is defining which part of the array am I considering right now. So first part, this was my middle element, this one's my middle element. How do I get the middle element? L plus u by 2. So this one is the middle element. So I saw that 88 is greater, so I ignored this part of the array entirely. We ignored this part of the array entirely. So my new array, the array where I can look for 88, is this. So my lower bound must be here. So my lower bound becomes mid plus 1. Lower bound becomes mid plus 1. Now we again saw 56. So this one was 56, this one was my mid, and 88 was on the right side. So we ignored this part of the array again, and this became my L. And then on the next thing, my next operation, I found 88 as my middle element, so I found my element here. Now some people sometimes have the confusion whether we should take seal of this or floor of this, because it can give you uh, in decimal, right? So it can give you something like 0.5. So what are we going to do? So you can take anything, floor or mid. Let me show you the algorithm first. So what we did, let me code it first. So suppose my at the beginning I am considering the entire array. So my lower bound is 0 and my upper bound is n minus 1. So I'm checking. How long am I checking? I'm checking till lower bound is less than equal to upper bound. Because lower bound cannot be greater than upper bound, so in that case the array does not exist at all. So this is our condition. We are checking from lower bound less than upper bound. So inside this, what we are checking is first we are taking mid. So my mid is lower bound plus upper bound by 2. So if you are using C++ integer division, if you had taken mid as integer, it will be already integer. In Python, you can just do this double sign. Uh, so, so if my middle element is smaller than my x that we were trying to find, so in that case, I'll increase my lower bound by mid plus 1, like you saw, mid plus 1. And else if so in that case, I'm going to decrease my upper bound by mid minus 1. And otherwise, this will be my answer. So I'll just return. So this will be my index where I found it. Otherwise, if I did not find it, so I'll just return at the end of the loop. I can just return -1, or I did not find it. So okay, I took a lot of time explaining the code. So I think you can understand what is happening here. So what I was saying was, some people sometimes get confused whether we should take floor of it or seal of it. So as long as you are using this L equals mid plus 1 and U equals mid minus 1, I haven't put the semicolons, please note those things. L equals mid plus 1 and U equals mid minus 1, you can take either seal or floor. So it doesn't matter. Like I said, you can it what we are trying to do here is reduce our work. We were going to check for in linear search, we are going to check each and every element. Here we are trying to reduce our array into half every time. So if it is one or two less or more, it doesn't matter. So you can take seal or floor anyway. But if you had done something like L equals mid, if you have done something like U equals mid minus 1, instead of minus 1, you had taken something like U equals mid. In that case, you have to make sure that you take floor here. Why? Because suppose you have, these are quite easy things, but I'm still saying because sometimes people get confused with these things. So if you have something like two elements in the array, like 7 and 9, and this is your lower bound, that is 0 index, and this is your upper bound, that is 1 index, and you had taken U equals mid. So my first, so if you had taken seal here, so my mid would have been 0.5, so seal would be 1, and my middle element, and you're trying to find 7, so my middle element would have been 9, and 9 is not equal. So what you are doing is, this is greater than x, so 9 is greater than 7, but you are doing U equals mid, so your U would have remained 1. So your U would have remained 1. You are not decreasing minus 1. So in that case, the loop would have gone forever. So in that case, you should have taken floor here. So I'll not confuse you anymore. If you are using L equals mid plus 1, U equals mid minus 1, you can just take floor or seal, anything out of it, anything out of these two, and that would work. Okay. So for floor and seal, sometimes you may need to find, suppose you have an array and you may need to find the smallest. Let me quickly show you some of the simple things. Like sometimes people get confused, so I thought I'll just show. Uh, so suppose you have want to find 10 here, but 10 is not here in your array, and you want to find the largest such number which is smaller than 10. So your answer will be 9. So we are calling this floor in the binary search, floor binary search. So for floor binary search, what you are going to do is make some changes here in the code. uh, you can make some changes here in the code, like you can take a floor value as -1, initialize it as floor -1, and when you have found the floor value, like where you are changing the L equals mid plus 1, you can take
Hello, Anushka, you there?
Am I audible?
Yes, now you are audible.
Okay, okay, okay. Sorry for that. Sorry for that. Let me. Okay, so what I was doing was I was showing you the floor value, right? So if you are trying to find the floor here, you can just use floor equals mid value here. So you can store the floor equals mid value here. And that will be giving you the value 9 here. So that is for floor, and you can use this kind of things for a lot of things. So suppose you are asked to find the square root. So I'll just give you some short examples. Like suppose you are asked. So suppose you are asked to find the square root of a number n without using the inbuilt square root function. Without using the inbuilt square root function. So you can use binary search for that. So one thing I forgot to mention is that the time complexity of this is log of n. Of binary search, the time complexity is log of n. Why? Because every time we are dividing the array into 2, so we are decreasing the length of the array by 2 every time, dividing by 2. So my time complexity becomes O of log n. So I'll show you the examples first, but first tell me if you had any kind of difficulty understanding the things that I showed till now. Was everything okay? You can ask me any questions if I missed something. After that, I'll show you some examples, small examples, or the places where I used binary search in my codes for in competitive programming questions. So I guess no one has any doubts. So we can go to the examples. So a very common example will be to find the square root of n without using the function, inbuilt function sqrt, math.sqrt that you have. So for that we can use binary search. So suppose you are trying to find the square root of 10, maybe 10. So that will be something like 3.2 or 3.16 or something like that. So you are trying to find the square root of 10. So your square root of 10 will lie somewhere between 0. So if it's a positive number, so it will lie somewhere between 0 and 10, right? So it will definitely be smaller than 10. It cannot be greater than 10. So you can treat this thing, your number line, as an array in that case. So your lower bound will be 0 and your upper bound will be 10. And you can treat this as a binary search thing. So here what we are checking instead, suppose we want to find the floor of this number, square root of 10. So you're trying to find 3 from 0 to 10. In this code, instead of finding the middle element of the array, so here your index represents your number here in this number line. So in that case, so if you have something like 0, 1, 2, 3, 4, 5, 7, 8, 9, 10, and this is your lower bound and this is your upper bound, and you're trying to find the floor of the square root of 10 here using binary search. So what you are going to do, you are going to find the middle element first. So this is your middle element, and you are going to check if this can be your square root. Can this be your square root? Your 5 square is 25, which is greater than 10. So no, it cannot. So you do not need to consider this part of the array or the number line anymore. You can ignore that. And this can become your upper bound now. And in a similar way, you can find it here. So that will be the floor of your, the floor thing that I showed you right before this. So you are trying to find 10 here and you'll end up at 9. That is the largest number that is smaller than 10. So this floor thing you are going to apply here. So it's a really simple problem. I'll not explain more of this. I think you can understand, right, how to do this. Let me know if I'm making things confusing or something. So you can find square root in that sense. Other examples can be, so suppose you have an array. Suppose you have an array and there are duplicates elements. There are duplicates elements like 5, then 7, 7, then 8, 8, 8, 23. And suppose somebody asks you to find the first occurrence of 8. First occurrence of 8. So this will be your answer. Or maybe first occurrence of 7. This will be your answer. So in that case, what we are going to do is we are going to use binary search for this as well. So this will be your lower bound, this will be your upper bound, and you are going to maintain the index at another variable. I should have written the code somewhere first. So you'll initialize some kind of index that we did not find anywhere. And then you're going to apply the same binary search technique, and I'll just code it again. I'll just hurry up and code it again. Let me. So it'll be in the same way. So while L is less than equals U, what we are going to do is you have your mid. You know how to find mid. Okay, I'm really sorry for that. I'll just code the things ahead of time from the next session. So we're going to check between L and U, and you have your mid that you can find using L plus U by 2 integer division. And if your array of mid is equals the target that you are trying to find, in that case your first position, you're not directly saying that that will be your first position. What you are saying is that the index can be your middle position now. So if you found 7 here, suppose you found 7 here, so you are saying that your 7, maybe this one may be your first occurrence, or it may be on the left side of it. It may be your first occurrence, or it may be on the left side of it. So you are checking further. You are going to check further. So what you are doing is mid minus 1. And otherwise everything remains same. So this is for code, this for Python. You can think of it this in C++ as well. So rest everything remains same. So only thing that we are only extra thing that we are doing here is we are, if we already found the thing, so if suppose we found 7 and we found 7 here, the only extra thing that we are doing in the code is that we are also thinking that maybe we can find 7 here as well. So our index will be our answer. So if we already got it, we are not stopping here, we are checking further on the left side of it. So I hope this example was clear. This is more of an interview type of question than a CP type. Okay. So this one was more of an interview type of questions. You can find these things on lead code. CP, I can show you some examples. I don't think is possible for me to explain a lot of the code that I wrote. But this one was a question from the qualification round of CodeJam. CodeJam, fourth question out of 5 questions. So there are 5 questions in the qualification round. And this was the fourth question. And it might be a little bit difficult to explain, but I'll just show you for motivation that binary search is used in a lot of places. So here the question, I'll just explain you to you in short. This is an interactive type of question, competitive programming question. So interactive question uh, problems are the ones where you can ask the judge, the online judge, questions. You can send queries to the online judge. So here the question says that you have n numbers. So if your n is 50, so that means if your n is 50, that means you have numbers from 1 to 50 in an array, and you need to find the order of the numbers 1 to 50. So the order of the numbers by asking the judge some questions. You need to find the order of the numbers 1 to n by asking the judge some questions. So what questions can you ask the judge? You can ask the judge, you can give 3 numbers to the judge and you can ask which one is the median of it. So suppose here, so see here, so you have 5 numbers, n equals 5. That means you have 1, 2, 3, 4, 5. So you have 1, 2, 3, 4, 5, and you are asking, you can ask the judge 60 questions. So first question that you asked the judge was, what is the median between 1 to 3? So what is the median between 1 to 3? So the judge said the median is 2. So you can use that answer of the judge and find your solution by that way. So that is an interactive program. You can ask the judge and the judge will respond to you. And you can use that answer. So in this case, this was simple 5, 4, 3, 2, 1. This will be different. So this is the answer here. I'll show you for this one. So this is 1, 2, 3. First, the question was asked that 1, 2, 3, between 1, 2, 3, which one is my median? So the judge said 3 is my median. So it will be something like 3 and 1 can be on the left side, 2 can be on the right, or this can be the case, right? The next question was 2, 3, 4, which is my median? So my median was 4. Between 2, 3, 4, my median was 4. So if my order was in this way, between 2, 3, 4, my median was 4. So I cannot have 4 here or I cannot have 4 anywhere here. My 4 must be somewhere here in the middle, right? 4 cannot be here because the judge says between 2, 3 and 4, my median is 4. So the order can be 2, 4, 3 or 3, 4, 2. something like this. So I have to place it between 3 and 2. So if this was my order, my 4 goes here. If this was my order, then my 4 goes here. So in a similar way, you have 3, 4, 5. Between 3, 4, 5, I have 5. So between 3, 4 and 5. So if I was taking this as my solution, between 3, 4 and 5, 5 was my median. So between 3 and 4, 5 goes in between that. Median. Median means the middle element here. So you can see my answer becomes something like, if I write it fresh in a fresh way, this one was 13542. And you can see that here in the interactive program, when you say 13542 is your answer, the judge says that yes, it is the correct answer. So here what I have done in my code, I'll not explain it in detail, but I'll just give you a rough idea on how I have used binary search in this question. Let me... Okay. So what I have done is I have initialized the positions. I have taken a dictionary and I have initialized the positions as their original position, their index position. So if I have 1, 2, 3, 4, 5, I have just given them, assigned them the position 0, index position 0, 1, 2, 3, 4, and I have asked queries like this in consecutive contiguous arrays of length 3, like 1, 2, 3. Then I have asked the judge if what is the median between 2, 3, 4, and then I have asked the judge what is the median between 3, 4, 5. So when I get the answer, suppose I have already the array arranged in a way. So I have the array arranged in some way. So it can be greater than 5, right? It can be 50, it can be 500. So I have the array, and now I have somehow uh, got the answer. So not somehow, I have asked the queries and got the answer for these many numbers here. And now I'm asking for these 3 numbers here. So there were other numbers before it. And I'm asking the query between these 3 numbers. And I have not asked the queries about these numbers after this. So at this point of time, I'm checking here. So what I'm doing here is, if my judge says that between this and this one, so indexing is done in the sorted order for at the beginning. So if this is my median, so it must be somewhere between here. And somewhere along the way, while doing the changes, my indexing has changed. Suppose this number, so the number I was checking between 3, 4, and 5, and suppose after doing some of the operations, my 3 has landed up here somewhere, and my 4 has ended up here somewhere. And somebody said that 5 is my element, which is the median. So I have to place 3 and 5 somewhere between 3 and 4. So it was not consecutive in the array because I had performed some operations. So in that case, what I had done was, I had checked which position to put my 5 in. So in my array, there might be some many other elements in between 3 and 4 because of the operations that I did earlier. So I had to change the indexing of 5 to something else. In that case, I had performed binary search. So I'll go here and check the median, which is the median between these 3 elements. So suppose this was 7, this was, I was checking for 5, and this was 11. So which one is the median? So if it's the judge says that 5, then I go here, then I can place it here. Or if it says no, that 7 is my median, so my 5 must go here. So in that case, I have for putting which one to put in the middle, I have used this binary search technique. It might be a little bit confusing, but you can think of this thing as an implementation of binary search. You'll not get direct binary search questions in competitive programming, but you'll need it as a tool somewhere. So here also this one was a question of snack down online pre-elimination round. So here what they have said is, and there is an array given, and you have to find the weight of every contiguous subarray of length at least 3. So if you have array given, maybe so your contiguous subarrays can be like this, or you can have like this. So for all such cases, that will be of O of n square type, O of n square. So I'm going from, I'm checking every contiguous subarray, and it has said to find the weight as the largest value of the weight in that subarray. So if I had taken this as my subarray, I need to find the weight of this subarray. And what is my weight of the subarray? Maximum of this. I'll take 3 elements out of this array. I'll take 3 elements out of this array, and bi minus bj multiplied by bj minus bk. So I had to maximize this thing. So how do I maximize this thing? So what I have tried to find using binary search here. If you see here, I have used binary search here, and I have tried to find the middle of the average of the lower bound and the upper bound. So if this is my 7 and this is my 32, I have tried to find 39 by 2, whatever that is. I have tried to find the floor of that number. So I tried to find the floor of that number. If I found the floor of that number, I have tried to check around that number. So that will be 39 by 2. That will be, so something like 11. 19.5, so that will be 11. So what I have done is, I have tried checking around 32 minus 11 and into 11 minus 7. So I have tried doing something like that, and I had used binary search here. So I did not explain the things properly, uh, because these things might be a little bit difficult, but this was just for motivation that you can use binary search as tools in a lot of questions. Somewhere you'll need to find some where the element exists. So in that cases, instead of using linear search, you can use binary search for making your time complexity less. So these were my examples. You can ask me anything. You can tell me if it was confusing, or if I need to explain anything more. If not, Simit can discuss divide and conquer from here. So I don't think anyone has any question. So I think Simit can take over from here. I'll just stop presenting.
Okay, so hello everyone. My name is Simit Nayan. I'm second year student of Information Technology Department at IIEST Shipur, and I'll be teaching you divide and conquer. So just let me know if my screen is visible or not. Is my screen visible? Is my screen visible? Can anyone confirm, please? Kiranma, you are not audible. Okay, okay. Thank you, Samit. All right. I'll be telling you about divide and conquer, and how it is helpful in solving various problems. So what it basically means, divide and conquer means uh, when we are given a problem, what we do is we divide the problem. Okay, we divide a problem into sub problems. Okay, or smaller problems. Okay, and what this conquer means, uh, we combine the solution of subproblems to conquer the problem. This is what divide and conquer means. Like this is a technique in which we divide a problem into various smaller subproblems or smaller problems, and then we use the solution to those subproblems, and we combine them, and we form the solution to our original problem. Like for example, we have a problem like pn is a problem. Then what we do, we just divide it into a smaller subproblem pn minus 1, and like we combine it with something. So using this, like I have divided this bigger problem into a smaller problem. Now this pn minus 1 can be further divided. This plus operation means combining. I'm combining the solution of the this smaller sub problem with something to form the solution to the bigger problem. Now this smaller sub problem pn minus 1 can be further divided into pn minus 2, okay, plus something. Now this can be further divided into pn minus 3 plus something, and we keep on doing it until, sorry, okay. So we keep on doing it until we have a problem which is simple enough for which we know the solution. Like for example, p1 is a very simple problem and we know its solution. Okay, so what we have done, sorry, pn was a very complex problem. We divided it into pn minus 1. It was still a complex problem. We further divided it into pn minus 2, and we kept on dividing it uh, until we reach p1. And for example, like we know the answer to p1, then what can we do? We can construct the answer to pn minus 3, and now we know the answer to pn minus 3. Now we will construct the answer to pn minus 2. Now we know the answer to pn minus 2. Now we can construct the answer to this. Now we can construct the answer to pn. Okay, so on a high level, uh, this is what divide and conquer is. This is the high level idea about divide and conquer. So I'll just give an example how we, like, now a question would be, till how long we need to divide the problem. Okay, now the answer to this is we keep on dividing the problem into smaller sub problems until the problem becomes simple enough. For example, let's take an example. Okay, okay, let's take an example. We need to find the answer to what is 10 factorial. Okay, now finding 10 factorial is not easy, right? Now, what we can do, we can just write 10 factorial as 9 factorial into 10, right? And 9 factorial is still very hard to find. Like we know that 0 factorial is 1. I mean, it is very simple, isn't it? So, but finding 10 factorial is really great, really very hard. So, uh, we divided the problem. This was our problem into a sub problem. Now, still, I can't find answer to 9 factorial. So, what I will do, I will divide 9 factorial as 8 factorial into 9. Okay, and I'll like keep doing it until I reach 0 factorial. Now I know 0 factorial is 1. So here uh, I'll be having 1 factorial into 2. Okay, that is 2 factorial equals to. So like I know 0 factorial is 1. So what I do, sorry, it will be something like 0 factorial into 1. Okay, 1 factorial. And 2 factorial will be equal to, sorry, okay, 2 factorial will be equal to uh, 2 into 1 factorial. Okay, now we know 0 factorial is 1. So what we do, we find 1 factorial using 0 factorial, then we find 2 factorial using 1 factorial, and then we find 3 factorial using 2 factorial, that is 3 into 2 factorial. Okay, and then we find 4 factorial, and then like we keep on doing it, and then we'll have the solution to uh, 10 factorial. Okay, now how can we achieve this? uh, uh, a very efficient way to like and very intuitive way to divide problems and conquer them is using something called recursion. So recursion is basically when a function calls itself. That is called recursion. So let me tell you something more. Like this case was simple enough. We knew the answer to this sub problem already. So this case is called base case. Okay, because this cannot be divided further. Okay, this problem was simple enough. So problem solution to a problem can be constructed using uh, two things: uh, solution to a subproblem and base case. Okay, so these two are very important parts to construct a solution to a problem. Uh, do you have any doubt till now? Okay, I hope you don't. Okay, now let's take an simple example. I uh, I already I showed you about how to find factorial. Now I'll show you. No, isn't this working? Okay, so okay, this. Uh, so I have a simple problem for all of you. We have a staircase. Okay, let's suppose we have a staircase, and it contains n stairs. Okay, there are n stairs, and we are initially here at level 0. Now it is given that at each step you can either jump one level up or two level up, and you need to count the number of ways to reach the top. Okay, so the problem is there are total n steps in a staircase. You are initially at level 0. Now you can take either one step or either two steps, and you need to reach the top. Okay, so how will you solve the problem? This problem. So let's suppose our answer is something like f of n. Okay, f of n is the answer to our problem. Now let's suppose we are here, okay, at n minus 1. F of n minus 1 will give us the number of ways to reach at n minus 1 at this level, and f of n minus 2 will give us the number of ways to reach at n minus 2. Okay, now this is our problem, and these two are sub problem. Now let's see how are we going to construct the answer using these two. Let's suppose we are here. From here we can take a jump of two steps to reach at level n. Okay, and if we are here at n minus 1, then here from here we can take a jump of level 1 to reach here. So the number of ways to reach at the top at n will be equal to number of ways to reach here plus number of ways to reach here, isn't it? So f of n will be nothing but f of n minus 1 plus f of n minus 2. And let's suppose we are at here 2. Then when n is equal to 2, then f of n will be, now we can reach at this level from either here or either here. Okay, so this will be equal to 2, and if we are at level 1, if n is equal to 1, okay, we are at level 0, and the question is to find number of ways to reach level 1. It is always equal to 1 because we can only take a step of 1 to reach here. So if n is equal to 1, f of n will be equal to 1. I hope this was clear. Okay, do you guys have any doubt? You can just ask. So let's see how are we going to construct our answer. Uh, okay, so let's suppose our function f gives the number of ways to reach at nth step. Okay, now as I constructed, like int answer will be equal to f of n minus 1 plus f of n minus 2. Okay, and we just need to return this answer. But if n is equal to 2, there are two ways. Okay, so we will return 2. If n is equal to 1, we will return 1. So these two are our base cases. Because these two cases were simple enough. We already know the answer to these cases, but when n is very large, we don't know answer to uh, this. So that's why we break it into sub problem and we find the answer. Okay, so if we pass, like, let's suppose int x, we take, I'll take it, and so let's suppose our n is 5. So if there are 5 stairs, then there will be 8. The number of ways to reach at the top will be equal to 8. I hope this was clear. Do you have any doubt? Okay. Now this problem was simple enough. Okay. Let's solve something uh, a bit complex. So I have already made some list here. Let's first skip this now. Let's solve this. Okay. So now the problem is, you are given a string. Okay. The string is like A, B, C. Okay. Now you need to find all the list of all the subsequence of this string. What subsequence means is, uh, subsequence is basically, if we delete any character or any set of character, then whatever we get will be subsequence of the original string. Like if we delete A, for example, original string is ABC. Okay. Now if we delete anything, like if we delete B, we get AC. AC is subsequence of ABC. Okay. Now if we delete AB, we will get only C. C is the subsequence of ABC. So subsequence is basically, by definition, uh, that can be derived from the given sequence by deleting some or no elements without changing the order of remaining elements. And it is really important. We are not changing the order of original string. A was before B, B was before C. The order will remain as it is. We can delete any uh, number of character from the original string, and whatever will be left will be the subsequence. Okay. So I hope what subsequence is clear to everyone. Now let's see how we can do it. We have ABC. Okay. Now let's suppose we have answered to the list of subsequences of BC. Okay. Now what can be the list of subsequence of BC? Forget about ABC. We are just focusing on this part, BC. Okay. Let's suppose we have, let's assume, okay, let's assume, we are assuming that we have the list of subsequences of BC. Okay. What are the list? What will be the elements in the list? Empty, empty string will be there, because empty string is a subsequence of any string. B will be there, C will be there, and BC will be there. Okay. Now for A, we have two choices. if we want to find the subsequence of ABC, we have two choices for A. We can either append it at the like before every string here, or we can we won't append. So we can like for example, we are not appending. So if we are not adding at the beginning of these a, we are not adding a at beginning of this all strings, then what will it be? It will be like this, then B, then C, then BC, then now we are uh, adding a at beginning of every string. Okay, now what will it be? A, then it will be AB, then AC, and ABC. Okay, so using the solution to this sub problem, this was our sub problem. Okay, this was our sub problem for this problem. For ABC, this was our sub problem. And what have we done? Using the answer to this sub problem, we have constructed the answer to our original problem. Okay, and we'll like keep doing it. Now the question can be, how are we going to find the subsequence of BC? Now what is the subsequence of C? It is empty string and only C. Now to find the subsequence of BC, what we can do, we can either choose to append at beginning of each string, or we will just keep as it is. So if we don't append, the list will be like this, and if we append, the list will be like this. Okay, so this we have constructed using this. I hope it is clear enough. If you have any doubt, please ask. How are we first constructing the answer using the solution to the the answer to sub problem? Okay, if you have any doubt, please ask me. Let's see how are we going to code it. Okay. Now we will just define a string s. We are taking a string from user, and now what are we? Let's just be clear what our function is going to return. Okay, our function is going to return a list of strings. Okay, so we are going to return a list of string, and let's name our function as subsequence, and we are passing a string to this function. Now uh, let's assume this is our answer. Now if a string is already empty, okay, so if a string is something like this, or this is an empty string, isn't it? So in that case, what are we going to do? We'll just add this pushback adds to a list. So we'll just add this to our answer vector, and we'll just return this vector. Okay. Now, let's suppose uh, the string, the length of the string was something greater than 0. Okay, if it was 0, this will be executed, and if it is not, then the remaining part will be executed. Now let's see. Uh, now let's assume our sub answer is something like subsequence of str dot from 1. Okay. What this function is basically doing, str.substr, is if we are passing a string a, b, c, d, e. So this is index 1, 0, 1, 2, 3, 4. Okay. So dot substr, what basically it does is it just cut off the uh, string from the index that we are providing. We provided index 1. So what it will basically do is from this whole string, it will just take this string out. Okay. So here what I have done is in this original function, I have passed the remaining string. So if my string was something like A, B, C, D, E, what I've done, I have just taken this string and I have passed it into function, this function. Now this, whatever it will return is my sub answer. Okay. So now what I will do, let's assume I have the sub answer, because this function is going to give me the sub answer. This function is going to construct the answer for this. And now we just need to focus on what we need to do with A now. Okay, so like, what was our first character? Our first character was something like str at index 0. Now what we'll do, we have sub answer. Okay, we already have a sub answer, means we have already constructed all the subsequence for this part. Let's assume I have already constructed for this. Now what I need to do, I just need to append a at the beginning of every string, or I won't append. So for a I have two choices, either I can append or I won't append. So I'll like, it's just a loop iterating through every element of sub answer. Okay. Now what I'll do, I'll just see plus, this means I'm appending for every string in my sub answer. I'm appending the first character with every string, and I'm pushing that to my answer array that I had constructed initially. Uh, this array is now empty because this block uh, was not performed. So basically, I have just taken the first character and I have added it to every string that was in my sub answer, and I have another option not to choose the first character at all. Okay, so I'll do something like this, and I'll just return my answer. Okay, now this is my subsequence list is equal to subsequence, and I have passed a string to it, and for each string in my subsequence list, what I'll do, I'll just print it out. Okay, so let's suppose I pass A, B, C, D, E. Now, as we know, like there are 5 characters. So for each character, we have two choices. Either we can take it or we won't take it. So the length of the answer would be something like 2 to the power 5, that is 32. Let's see. Let's see. Okay, sorry. Okay, so you can see here I have the list. There are total 31 elements now. No, there are 32 elements because there is empty string here. Uh, it is not showing. So you can see now these are all the subsequences of A, B, C, D, E. I hope you got my point. So if you have any doubt, please ask me. Uh, okay. So I have another two problems. Should I do it now or should I give it to you? Like, should I show more examples or should I like? I hope you got the point how we are using recursion. Okay, Vikram said he would like to try. All right. Okay, yeah, definitely. Rahul is asking, Bhaiya, can you explain when the recursion stop? Okay. Okay, this is an important question. When the recursion stops. Let's see. Actually, let's see. For which question you wanna know, Rahul? When the recursion stops, the first one or the second one? Okay. So this one. Okay, great. Originally, we had A, B, C as our substring. Oh, sorry, as our original string. Now, what we did, let's just go and we just called this function and we asked the answer to the sub problem. Means we asked the answer to what will be the list containing subsequence of BC. Okay. So once we get the subsequence containing BC, we just had two options. Either we appended A to it, or we just left it as it was. Okay. So now what I did, I called this was my function. I then again called my function with BC, isn't it? In BC, like this was my function. Originally, it had ABC. Okay, I passed here ABC. I constructed a vector. The length of the vector was not 0, so this won't be executed. Now I passed the remaining string, that is, I passed the BC. Okay, so here BC was passed, or I can just make a tree like this. So here BC was passed. In BC, C was passed. Okay, when C was passed, what I did, C has only one character. Okay, so what I did, I uh, let's let's suppose C is made like this. Now what I did, I passed the the substring after C. Now after C, it will be empty. Won't it be empty? Like this is like if you consider this as C plus, okay, that would be more confusing. But what I'm doing when I pass C, I asked my sub problem is this empty string after C. So in C, I passed this empty string. Now the length of the string is 0. Now what will happen? This will be executed. Uh, I made an answer vector. Okay. In that, I appended a empty string and I returned whenever this return statement is called. At that point, uh, the function terminates. Okay. So this length was 0. Here length 0 was uh, like encountered. Then these lines won't be executed. Here only the function will terminate. Okay, so here the function was terminated and we went back to this. Now for this uh, for this part we are asking, we had called in level C this, then only this empty string was called. So in level C, at this level, take it as let's see, this is made up of different levels. At this level I already returned, so this level is like shattered, you can say. Now I'll come back to this level, and here I'll just perform this and then return the answer. So from here I'll return something, and then from here I'll return something, and from here I'll return my the list containing all the subsequences. So the recursion stops when it hits the base case. Okay, so you just need to keep in mind that this was my base case, and the recursion will stop when it will hit the base case. I hope it is clear now. Okay, if you have any further doubt, you can just ask. Uh, okay, I'll just send this problem, and I'll ask you all to try, and then we can have discussion after you try. Okay. If you have any further doubt, you can just ask. Okay, I hope you got an idea of how we divide and conquer the problem. So, okay, we can end the session now then.